Okay, so today we are going to do 311, but I want to first go over a problem on the test that was heavily asked about, and that was this pattern problem. So really you guys did good on the A and B part. What does the fourth figure have and what does the fifth figure have? That really was not an issue. So if I look at this, I can see the first figure has 5. Oh goodness, that looks terrible. Let's try that again. So the first figure has 5. The second figure, when I count those dots, I see that it has 8, and this one has 11. So hopefully that you noticed it was going up by 3 each time. So remember that that 3 is our multiplier. Okay, that tells us what we're going to multiply the figure number by to get how many dots. Now, sometimes there's extra steps to it, so you can't just say oh, 3 is my multiplier and call it a day. So if we do 3 times our figure number, okay, and I can always go back and check it, okay? So if I said 3 times the figure number, so for this one, 3 times my figure 1, that gives me 3. But the problem is I have 5 dots. So I think to myself, what do I have to add to 3 to get to 5? Oh, well, that's just 2. Great. If I do this one, 3 times my figure number 2, well, that's 6. I have 8 dots. So what do I have to add to it? 2. And hopefully you'll see a pattern that it's 3 times the figure number plus 2. So for this 30th figure, 3 times 30 plus 2. And that's where you would get 90 plus 2, which is equal to 92. So I know that really doesn't have anything to do with our notes today. I just wanted to make sure to go over that while it was kind of still fresh in your brains and make sure that I can explain that to you. All right, let's go ahead and do 311. So please make sure that you have a note sheet and a pencil and you are ready to go. If not, go ahead, pause this and go get those items and get ready. Okay, so 311 notes, we actually split up into 2 days. So you're going to do half of it today. You'll do the next half on Monday with me in class. So your homework for 311 will not be due until Tuesday, October 18th. Okay, so you have this weekend and Monday night to get that done. Please remember that your test corrections are due on Monday for Chapter 2. I am not accepting them after that. Okay? All right, so let's jump into the fun. So 311, using the multiplicative identity. So in this lesson, you'll analyze a powerful tool for finding equivalent fractions. This way of thinking about equivalence can be applied to many different situations. And this is going to be something that you're definitely going to see again in 7th grade. So you want to make sure you have a good understanding of it here. So when you go further in math. It says, Miss Vasquez, that's what we're calling her, has a reputation for telling math jokes. She started class today with this one. Ron was picking up his pizza at the takeout window. The clerk asked him, do you want your pizza cut into 8 slices or 12? You better cut it into 8 slices, Ron replied. I'm not hungry enough to eat 12. Okay. Some students thought the joke was funny. Do you? I'm sure that about just knowing you guys all laughed at that. I just know that's right up your guys' alley and your sense of humor. So I'm glad I could grace you with that. But really though, what is the fraction concept that makes the joke work? So why is that funny? Why does it make sense to say, oh, I'm not hungry, cut it into 8 pieces than 12? So go ahead and think about that. Why does this joke work? So go ahead and pause and think about it. Okay, so cutting the pizza, so cutting, and I am writing at a really weird angle, so I apologize. Okay, so cutting the pizza, that would be like your whole, okay? That's what we're working with. That is one whole pizza. Into 8 slices or 12 does not change the size. Goodness, my handwriting is terrible like this. Just the size of each slice. So I'll read that again because that is hard to read. It says cutting the pizza, or like our whole, into 8 slices or 12 does not change the size of the pizza. So I'll make that pizza. Okay, it just changes the size of each slice. So if I go to Papa John's and I get a medium pizza and I say, oh, cut it into 12 pieces, not 8. I'm not getting any more pizza. Really, the size of my slices just got smaller because the more you cut something up, the smaller it gets. So it's not like a cool trick to go to a pizza and be like, watch this, I'm going to order a small but get so much more. No. Okay, unfortunately, I wish that's how pizza went, but it's not. So, all right. So let's actually look at this again. So it says less is more. Frankie's mother made a big pan of lasagna last night. She cut the lasagna into fourths and ate one. Then she put away the 3 pieces of leftover lasagna by cutting them each in half and repackaging the results. This process fascinates Frankie. How can you make something smaller and still end up with more? She asked. Write a fraction representing how much lasagna was left over after Frankie's mother ate dinner. Write another fraction representing how much lasagna was left after it was repackaged. Does she really have more lasagna after repackaging? So we need to take a minute, pause this, and go ahead and see, first come up or write a fraction of what was left over after she ate. So before she cut anything up, what was left over? What fraction of the lasagna? Then go ahead and write a fraction of after she cut everything up. How much did she have? So go ahead and pause and solve for that. So the fraction of lasagna she had left over, okay, right after she ate, before she cut anything up, she had this lasagna and she cut it into fourths, so 4 pieces, and then she ate one. So how much was left? 3/4. Okay, and the numerator represents how much was left over, and this was how many pieces there were to begin with. So you can see the leftover number is your numerator, and how much you started with is that bottom number. Now, when she went to put this away, okay, she cut these pieces in half. So in here, here's the eaten piece. Okay, she cut every piece in half, and then she put it away. So how many pieces did she have left over? Would be 1, 2, 3, 4, 5, 6. She had 6 out of 1, 2, 3, 4, 5, 6, 7, 8. So she had 6 left over. And this was out of 8. Okay, because remember, this is out of what was the total. Okay, so yes, she ate a piece, but remember at one time that was a whole lasagna. Okay, so that's where that 8 came from, is because that is what was there to begin with before she ate a piece. If she cut all those 4s into half, she would have 8. So it says use what you know about fractions to explain. You could say she ended with twice as many pieces but they are half as big. So yeah, she ended up with double the amount of pieces from the 3 left over originally, but they're all much smaller pieces. So this idea of a giant 1 is going to be really important and really what's going to stick with you in 7th and 8th grade. So let's look at the bottom of 311's notes. It says, Frankie was thinking about her mother cutting up lasagna when she noticed a very useful connection. She recognized that any fraction in which the numerator and the denominator are the same is equivalent to 1. In addition, multiplying a number by 1 leaves that number unchanged. So I really hope you already know that. Any number multiplied by 1 is itself. So 2 times 1, 2. A million times 1, a million. Okay? Wow, she said, I can use this idea to find a whole bunch of equivalent fractions. She showed her team the work at the right. Look, she said, it's the same as using a giant 1. So when you create equivalent fractions, they are equal to each other. So if I said, do you want 3/4 of my candy bar or 6/8? You're getting the same amount, just like up here. This 3/4 and 6/8 are the same. The pieces are just smaller. So you're still getting this chunk of the lasagna, but your pieces are smaller. So they are the same, okay? And so when you multiply by this giant 1, which remember any fraction equal to 1 has the same number on top than bottom. So if we look over here at the right, she multiplied the top and bottom by 2 to get an equivalent fraction. Remember, equivalent means same. So she multiplied by 2 over 2, which is equal to 1. So some people get confused. You're like, well, we're multiplying by 2. Yes, but you're multiplying by 2 over 2. So you're just taking that fraction and you're cutting it up more. So we're going to use this giant 1. So it says, discuss Frankie's work with your team. Does it make sense? Is 3/5 equivalent to 6/10? How can you be sure? So go ahead, take a minute and think about it. Is 3/5 equivalent to 6/10? And you can think about, yes, because 3/5, if I multiply it by 1, so excuse my terrible draw, that looks terrible. Sorry. Okay, I'm not sure if that looks better, but we're going to roll with it. So 2 over 2, okay, yeah, we're working with 2's, but 2 over 2, remember, is like 2 divided by 2, which is equal to 1. Okay, and you multiply the top and the bottom by the same number, you get an equivalent fraction. So is 3/5 equivalent to 6/10? Yes. Okay, and how can you be sure? Because you multiplied 3/5 by, and we're going to put 1 in quotations, because yes, it is 1, but we're using 2 over 2. Okay, and anything times 1 is itself. So you can multiply that and use a giant 1 of 1,000,000 over 1,000,000 and get 3,000,000 over 5,000,000. That's the same and it's equivalent to 3/5. Again, if I come up here to this lasagna, okay, I have 3/4 left over. It's also like saying I have 6/8 left over. It's the same amount, just smaller pieces. So now I want you to find 2 equivalent fractions to 3/5 that other than we use. So do not use 6/10. So find 2 new ones. And go ahead and practice using that giant 1. Okay, so you should have just found 2 fractions. So here's my giant 1. And I'm going to we'll just use 3 over 3. Okay, 3 times 3 is 9. 5 times 3 is 15. That's an equivalent fraction. Another one would be, well, let's just keep this pattern going. We'll just use 4 over 4. You could have used any number, as long as you use it, same number on top and bottom. So 3 times 4 is 12. 5 times 4 is 20. Okay, so that's 2 other fractions. If you multiply top and bottom by 10 over 10, then you should get 30 over 50. Multiply top and bottom by 7 over 7, you'll get 21 over 35. So there are 1,010 reasons. You could sit here for the rest of your life and create equivalent fractions. It'll never end. So your answer may be different than mine, and that's okay. Just make sure what the important piece is that you multiplied by 1, which is a fraction with the same number on top and bottom. All righty, let's go ahead and flip to the back. And it says, what Frankie calls a giant 1 is more formally called the multiplicative identity. The multiplicative identity states that any number multiplied by 1 is itself. So all that's saying, the multiplicative identity, is when you multiply a number by 1, you're going to get this number you multiplied it by. Okay? So go ahead and pause this video and try to find 4 fractions, or at least 4 fractions, that are equivalent to 9/8, and I want you to use that giant 1, because I want you to get used to seeing that and using it. Now, in future, you don't always have to draw the 1, but I want you to get used to that now. So go ahead and pause the video and do that. So I went ahead and set mine up so that you didn't have to watch me draw each one terribly. So you could have used really any giant 1 you wanted. I'm just going to use the couple that I have. But if you use a different one, that is okay. So 9 over 8, which if you recognize, that is an improper fraction, which means the numerator is larger than the denominator. That's just a fun fact for you. You can put that in your pocket and, you know, use it on any day you need. All right. So going across, I'm just going to start with 2 over 2. So 9 times 2 is 18. 8 times 2 is 16. And since we're working with improper fractions, your answer should always be 1 as well. All right, let's use, I don't know, 3 over 3. 9 times 3 is 27. 8 times 3 is 24. Again, improper fractions, so it's looking good. Let's use 4 over 4. 9 times 4 is 36. 8 times 4 is 32. Again, improper fraction. And then let's get real wild and crazy today. It's Friday, why not, right? We'll use 100 over 100. So 9 times 100, 900. 8 times 100, 800. Okay? That is what we mean by the giant 1. Okay, so now we're going to go to 3, 5. So many choices. All right. Bertrand was feeling confused. There are so many ways to write the giant 1. How do I know which one to use? He whined. How can Bertrand decide which giant 1 to use? Work with your team to answer the following questions to come up with a strategy. So you're going to look at what it gave you. So I multiplied this 4 by something to get 44. So I have to think about, what did I multiply 4 by to get 44? Oh, that's 11. Well, remember, we're making equivalent fractions. So what I do to the bottom, I have to do to the top. So 3 times 11 is 33. So my giant 1 was 11 over 11. All right, go ahead and pause and fill out the other 2, and then play this when you're ready. Okay, so again, you had to think about what times 12 gave me 60. Oh, well, that's 5. What I do to the bottom, I do to the top. 7 times 5, 35. Okay, same thing here. They just wrote it backwards. Same concept. What did I multiply 3 by to get 18? Well, that's 6. Since we're making equivalent fractions, I multiplied that by 6. So I had to think about, what did I multiply 6 by to get 72? And hopefully you got, that is 12. So sometimes you're going to have to work backwards. Now, I'm not going to have you do this one. So you are done with notes today. So go ahead and get out your homework packet. If you did not get one, please go up to the sub, and there is a box behind or against that back wall under my window of the homework booklets. You can grab one. And 311 is due on Tuesday, so we'll do the other half on Monday. All right, I miss you guys so much already, and I hope you guys have a good day and a good weekend, and I will see you on Monday. Bye.